I would like to go into the actual topic of today, OPC UA for geometrical measurement systems, or if you want to see the number, then it's OPC 40,210. And I'm very happy that we have Dr. André Scheller as our expert today giving the presentation. He is the chair of this working group, OPC UA for GMS, and he will tell you now more exactly what a GMS is and what was done with this working group and what you can expect to find in regard to OPC UA for GMS. So, André Scheller, welcome, and the stage is yours.
Yeah, hello Heiko, thank you for this very kind introduction, and ladies and gentlemen, welcome for attending this or today's Shopfloor data session. I'm very proud and happy that I can talk today about, as Heiko mentioned, about OPC UA for GMS, geometrical measurement systems. So let me start with a little outline. First of all, I would like to give a little introduction into the topic, into this domain of GMS. Afterwards, we will speak about use cases and the reasons for the standardization. Then I would like to introduce you to the information model. I mean, this is a more technicalized or a more technical presentation. I mean, you're the experts in implementation, and this is what the target group of this presentation is all about. And we will close with giving some examples and also a kind of future outlook for the GMS session or for this GMS working group. So let me start. So what means system of interchangeable parts based on information from measurements? Imagine that you are, let's say, an engineer who wants to manufacture some kind of part. You make your drawing, you make your, let's say, you give your tolerances for the manufacturing machine, and then it goes into manufacturing and this part is produced. And afterwards, who can make the quality or who can measure the quality? This is exactly what measurement system is all about. So what we need is metrology, especially dimensional metrology. You need this if you want to determine the characteristics, or if you want to inspect the part that you have produced. And what does that actually mean? What is metrology? Is this kind of, let's say, large device, which is sketched here on the bottom of this image? Of course, it's not. So dimensional metrology or geometric measurement systems can be starting from a small caliper here, which you see on top. Small device, handheld, manual operation usually, and it can be a very large, up to a very, very large system, which is integrated directly into the shop floor. So when we started this working group, we made our mind about, okay, there's a broad variety of measurement instruments. How can we summarize them? How can we categorize them? And how can we describe them in a more standardized way? And this classification, by the way, was derived from the ISO standard for GPS, for geometrical product specification. So when we have this, we have the measurement in mind, we want to analyze what are actually the reasons for this characterization, and from that, from our requirements, how can we define use cases, which we then model within the framework of OPC UA. So as I mentioned before, the geometrical measurement systems, they are an essential part of the shop floor, usually after or close by production. So imagine you have some inspection planning, you have a drawing, and you say, okay, I want this part or this hole to be, let's say, I don't know, 0.5 centimeter or something like that, and you have some tolerances and so on, and you put this into your drawing, let's say, and you have tolerances, you have the characteristic, and the features or the characteristics you want to measure. And then afterwards, after the manufacturing process, you have the data acquisition phase. That means you take your part, you measure it, and maybe if you see, okay, after manufacturing and the inspection step, there has been something wrong, I need to remanufacture, or the part is okay, and then you're done, so to speak. And of course, what goes hand in hand with the things I described above, you have to analyze your measurement data. So this is also, let's say, part of this GMS, let's say, workflow. Yeah, so you collect data, you collect results, and you analyze the data. So how does this actually fit into a more broader scope in the shop floor? As you usually start with developing some kind of work piece, and then after the development and construction phase, you start with the work planning, where you actually say, oh, my machine tool, so to speak, it has to produce from this kind of metal box, let's say, these parts. You go into the manufacturing phase. And within this manufacturing, and you also have this measurement. And then after analyzation, you can decide, okay, it's a good part, or this part is not good. And then remanufacture, or you just throw it in the rubbish, colloquially saying. So what is this actually? Say here, this is the horizontal value chain. And of course, these pieces are interconnected, not only the work planning, but also with the whole production planning. And of course, if you have recorded the quality of the part that you have measured, you want to send this to an external communication system, let's say higher level system maybe, or some website, or the an external third-party quality system. So this is usually the integration into the horizontal shop floor. But of course, there's not only the horizontal integration along the, let's say, factory shop floor. There's also some kind of virtual integration. And this is a picture which most of you are quite familiar, I guess. This is the vertical automation pyramid, where you start, let's say, on the very, very low level, or very, very in the first level, not the low level. Actually, you start with sensors and actors, then you go high above this ladder, so to speak, or the automation pyramid. You go to monitoring and control systems, then you go to some manufacturing and operation systems, and you end up with a, let's say, global enterprise resource planning system. So the data is transferred from bottom up, and the planning goes from top down. And how does both parts fit together? This is shown here in this picture, where we see, okay, we have this horizontal integration and also the vertical integration. And this is actually what we wanted. This is the challenge that we wanted to tackle. So how does this, let's say, measurement device, which can be tactile or optical, I forgot to mention that before, there's a variety of sensors. How can this be integrated into the horizontal and vertical, let's say, shop floor? Okay, and of course, people have made up their mind before, so OPC UA is not the first one. Without any, let's say, without completeness, I should say. Here are a few standards, and also, let's say, standards and norms which have been developed before and which exist. So, for instance, the E++ VDMA, for instance, or AcuDev as an analysis transfer format. And of course, the challenge was there are some standards, and OPC UA, if it is new, should somehow relate to the standards. Maybe we can adopt things as we have seen before. We adopt the device classes in OPC UA. And in the end, this is our main goal, that we build really a harmonization within the GMS. So within GMS, I mean starting from a small caliper to a really full-scale inline production measurement device. Okay, so now I speak about where is the GMS living, so the geometrical measurement device living. What are use cases that we can derive from that? And this is what I will show you now. Of course, imagine you're an operator and you want to see, okay, which devices I actually have in my portfolio. So which can I use, for instance? I have a part and I want to inspect this. And this was our first use case. So we want to record static machine data. So this static machine data already tells you a lot. It tells you which machine you have. It tells you, for instance, what software version is developed, what software version is installed on this machine. It tells you the basic machine capabilities. So this is the wrap up. The static machine status allows to identify machines and to track their capabilities for inspection. But that's not all. I mean, imagine you're an operator, so you also want to know how are my machines doing in the shop floor. Imagine you have let's say 5 assets, 5 machines, and you want to see, okay, what is the overall equipment effectiveness, or how are the machines operating, how are they running? I will come to KPIs later on, but you can actually, within the framework of our OPC UA standard, say something about the dynamic machine status, which we adopt from other standard OPC standards. I will come to that later, but the use case is quite clear. I want to see, okay, my machine is operating, it's not operating, maybe it's in an error state, who knows? With OPC UA, you can get this information. Let me come to another use case. As I mentioned, so we provide the quality for the parts that have been produced. Now imagine you have a part, let's say 4312, something like that. And I want to measure it. I have a measurement routine, I have my part, and then I want to say, okay, my measurement results should be linked to this part information. And we are linking actually, OPC UA GMS should be able also to contribute, for instance, to digital twin applications for this part. So we are an integral part for the quality of the produced part. Then let me drop a few words on this job management. This was also one of our, let's say, use cases from the starting point. Of course, this is a goal to control machines via OPC UA. And we have seen before that, for instance, machine tools, they have also some job monitoring, and of course, as I will say later in the detailed section, we rely a lot on these machine tools. We want to see, okay, what is the next measurement routine? For instance, or is the machine already ready for measuring? Is there any loading? Is this part loaded, which has to be measured? This is our use case that we want to provide. And as a little teaser, of course, we have an ongoing development. There happened a lot, especially for job management, and this is something that we will address in the near future. Last but not least, one of the final use cases that we wanted to achieve, I mentioned, the data flow, quality data which we acquire from within the shop floor has to be collected, has to be, let's say, transferred to a higher level system. And GMS, OPC UA standard, shall provide these measurement results and shall give a framework where I can retrieve measurement data. This include not only the characteristics, but also correction values. Okay, now let's put this all together. Just a quick reminder, we've seen before, we have the horizontal integration, the vertical integration, and marked in orange, the use cases which we wanted to tackle. And this is actually what we did within this working group with the VDMA. Actually, we developed, or let's say, let me drop a few more words. So the initial kickoff meeting for the OPC UA working group was in September 2019. The initial phase received financial support from Hexagon, Jenoptik, Ma Post Mitutoyo, OGP Messtechnik, Wenzel Metrology, and Size IQS. And together we worked on this companion specification, and it was quite a tough task, especially because of the Corona pandemic, where we met a lot of times online, not in person, but in the end we managed it. And moreover, we received excellent academic support by the Institut für Steuerungstechnik und Werkzeugmaschinen from the ISW Institute Stuttgart. In the end, actually, we managed to get the first, let's say, the first release in May 2023. But of course, after the release is before the release. Yeah? I will come to that later on. Let's first have a closer look onto the information model. I brought to you 2 pictures and also the link to the standard, which is given below. And what you see here on the left-hand side is, let's say, a little bit blurry, by the way, is a screenshot of a minimal implementation of a GMS. And with this minimal implementations, you already see the main features which are covered by the standard. You have an identification, you have equipment, you can send notifications, you have the active program state, and of course, you can provide results. On the left-hand side, there's this UML chart where we, and my intention for bringing you this graph was, I want to say, of course, OPC UA for GMS is not an invention on its own. Of course, we rely on prior work. Of course, we rely on excellent other standards. For instance, as I mentioned, we have the machine state, which we in GMS take from the OPC UA machine, OPC machinery. We have a lot of things which we actually, especially monitoring, which we actually inherit from machine tools, monitoring, but also, let's say, the program state and also the tools. So let's say tools in our language are the sensors, but there's a close connection. And we from the GMS working group believe that relying on this, on inheriting from the other standards, makes it easier for implementation and makes it easier also for the later customers to adopt this as a new and valid and also viable technology. Yes, let me just briefly, we collect a few snapshots from the standard, but it's more important what I say than what is shown here. You can look it up all in, if you want, 1,000 times afterwards, because you get the slides and also the videos. So what is new here and what is essential for a GMS is that the machine which you use for measurement is calibrated, because this calibration tells you that the result that you receive, the characteristic that you have measured actually, that this quality data is really sufficient, that this quality data is valid. So what we implemented actually was a calibration prognosis type, which is essential, especially for the GMS. And which is new for GMS, and which was not, let's say, in machine tools, is the handling of results. As I mentioned before, we can not only transfer results within the OPC framework, we can also describe our characteristics, let's say the roundness, or let's say a length of a screw or whatever. And also we can provide correction and correction values. Moreover, we have also implemented events like the intermediate result event and the result ready event. And this is new. This is, let's say, essential. But as I mentioned, we're not fixed with that. Yeah? So this is the information model as it is now. Of course, we want to continue, and we see that within the OPC UA, the OPC and OPC UA community, there are strong drivers, there's strong development, a strong community, and of course, the standards which we rely on also are undergoing active development, and I'm very happy that I can work especially with colleagues from machinery, from machine tools, but not only, from all other working groups. And we want to continue, we want to go ahead one step further. As I mentioned on one of the slides before, there is some kind of job management implemented, which is basically monitoring as part of the standard today. But in future, this will change. In future, we want to rely on a harmonized job management. This is shown here, marked by, let's say, future development 1. Not only, as I mentioned, we have some static and dynamic machine states. And we want to integrate this into KPIs. And in the end, this is our goal, this is our hope, that GMS, like any other kind of system in the shop floor, can provide and can deliver some kind of overall equipment effectiveness. And there are other KPIs which you can actually contribute. For instance, how many good parts, how many scrap parts have I produced? Since we provide the quality of the data, we can do so. And last but not least, energy, saving energy or handling energy, because you cannot save from a physical perspective, you can only change. Handling energy is very a tough task, especially in terms nowadays where we face the climate crisis and we have to rely on some energy management. This is also something that we want to address. We want to provide tools within the OPC framework where we say, okay, we can contribute to intelligent energy management systems within the shop floor. And with that, I'm almost done with my presentation. Let me provide some few examples. So I was very happy because in 2022, prior to the release of the standard, we were already part of the UMATI community. We means most of our contributors from the working group. We were part of UMATI, and the FR Services GmbH, they have, let's say, they have adopted the OPC GMS for UMATI. And because we rely heavily on machinery and machine tools was already at UMATI, this was a good decision actually. And I mean, the link is provided here. You can do so. Let's say just you can in the aftermath, if you have the time, you can go to UMATI. So what is shown here, you see some screenshots from the web page actually, and you see, okay, we have again this machine data, especially for GMS. We also have the calibration information, whether or not a system is calibrated. We have dynamic machine data where we say, okay, this and that tool is loaded, the sensor. We have the active program and the active part data. We have some kind of monitoring. And if you're interested, I forgot to mention, of course, you have also the measurement results. I will show an example later in a little bit more detail. And of course, as I mentioned, UMATI is a strong community. You can look at the QR code, go to the umati.app. Let me provide a few more examples. For instance, as I mentioned, GMS is not only a big, huge machine within the shop floor and also big within the production line or in a, let's say, manufacturing center, it can also be a hand tool, a manual device. I'm very happy to bring you this picture actually, because within the framework of UMATI, you also provided a software component for a caliper. And with that caliper, you can measure something, a screw or whatever, and you can go to the UMATI webpage and immediately interactively look at the results. And this caliper approach has been quite successful actually, because it's permanently now in China. Look in a permanent exhibition. But not only that, I have another example, this time from SAIS, where they provided an OPC UA server, and this OPC UA server, which is located on the machine, actually contributes to a higher level system. So this is a real use case for a real implementation, a real success story. And if you're more interested into size machines on the this time on the Umati dashboard, I also provide you the QR code. But it's not only Umati. I have a third example where one of the colleagues from the working group actually implemented his own website and his own IoT platform based on Node-RED. So as you have seen, there's a lot of things that we actually can achieve when we implement OPC UA for GMS. And with that, I'm almost done with my presentation. And I would like to come to the conclusion here. So what are the key takeaways? What are the lessons learned for this data session? The OPC standard for geometrical measurement system enables several use cases. We have talked about a few: the machine state, job monitoring, and results transfer, just to name it, part transfer, and so on. We've also seen that we are part of the Umati community, and a lot of machines are actually within the Umati dashboard, which is really a success story on its own. And last but not least, we've also seen that we are under active development and active community, and we will further adopt to our customer needs. And with that, I would like to finally thank you for listening. Thank you for your attention.